Chapter 14, Section 2, Climate Classification. So the main idea for this section is that climates are categorized according to the average temperatures and precipitation amounts. So earth science for you. What sort of place comes to mind when you think of a vacation in a tropical climate? A place with hot weather and a lot of rain? If so, you already know something about tropical climate, even if you have never visited one. Okay, the Köppen classification system. So the graph on the left in Figure 5 shows climate data for a desert in Reno, Nevada. So Chapter 5 or Figure 5 is down here. So we have Reno, Nevada on this side. The graph on the right shows climate data for a tropical rainforest in New Guinea. What criteria are used to classify the climates described in the graphs? So this is our rainforest in New Guinea. If we look at our legend down here, the red, the bars across the bottom here, that's precipitation. Just like this is precipitation here. And then this area here is your average temperature, the line going up this way, or the line going straight across here. So that's our temperature. If you notice this graph, you have to be careful with these graphs. They do have 3 axes. So you have the month across the x-axis. Your first y-axis shows precipitation. The second y-axis on the other side is for temperature. So you have to be careful with that. Temperature is an obvious choice as is amount of precipitation. The Köppen classification system is a classification system for climates that is based on the average monthly values of temperature and precipitation. Developed by German climatologist Vladimir Köppen, the system also takes into account the distinct vegetation found in different climates. Köppen decided that a good way to distinguish among different climate zones was by natural vegetation. Palm trees, for instance, are not located in polar regions, but instead are largely limited to tropical and subtropical regions. Köppen later realized that quantitative values would make his system more objective and therefore more scientific. Thus, he revised his system to include the numerical values for temperature and precipitation. A map of global climates according to a modified version of Köppen's classification system is shown in Figure 6. Now, yes, temperature and precipitation are the better values to have, but to have these averages for those, you have to have a lot of data. Whereas vegetation, plants have very specific requirements for where they grow. The vegetation's already there, so you can just look and say, oh, there's cactuses over there, that's a desert. There's palm trees here, that's probably tropical. There's a lot of oak trees here, that's probably temperate. So, vegetation was a very easy thing to look at to classify these. All right, worldwide climates. So Köppen's classification system, shown here in a modified version, is made up of 5 divisions based on temperature and precipitation, and then there are subdivisions of those. Okay, so we have some examples here of a highland climate in Canada here, an arid climate in Australia. You have a semi-arid climate in Argentina. But if we look, we have tropical climates, we have mild climates, we have dry climates, we have continental climates, and then we have polar climates. And then those are divided into other climates, and subtypes. So tropical climates, you have tropical wet and dry. You have mild climates you have Mediterranean, humid subtropical, marine west coast. You have semi-arid and arid dry climates. You have warm summer, cool summer, and subarctic continental climates. And then polar climates, you have tundra, you have ice caps, and you have highlands, which aren't necessarily near the poles, but they are like at the tops of mountains. So highlands would be like up here. All right, tropical climates. Year-round high temperatures characterize tropical climates. So one of the main things for tropical climates are these year-round high temperatures. In tropical wet climates, the locations of which are shown in Figure 6, high temperatures are accompanied by up to 600 centimeters of rain each year. The combination of warmth and rain produces tropical rainforests, which contain some of the most dramatic vegetation on Earth. Tropical regions are almost continually under the influence of maritime tropical air. The areas that border the rainy tropics to the north and south of the equator are transition zones known as tropical wet and dry zones. Tropical wet and dry zones include savannas, like the Lion King. These tropical grasslands are found in Africa, among other places. These areas have distinct dry winter seasons as a result of the seasonal influx of dry continental air masses. Figure 7 shows average monthly temperatures and precipitation readings for Normanton, Australia, a savanna in northeast Australia. So if we look over here, we kind of see January, February, March. You have a lot of rain. You have a lot of rain in December. So this would be your wet season. And then May, June, July, August, September, October, that would be the dry season. There's not a lot of rain right there. Now you may think that we said these areas have distinct dry seasons, usually in the winter. I don't think it actually said that, but in Australia, this is the winter. The winter is that May, June, July, August, because it's southern hemisphere. So you have this cooler time period here too. So during that winter period, you have cooler weather and it's dry. During the summer, it's warmer and wetter. All right, dry climates. Dry climates, which cover about 30% of Earth's land area, make up the largest climate zone. So dry climates make up the largest climatic zone. Most of the world's deserts, such as the Sahara, the Gobi, and the Australian, are classified as dry climates. In these climates, continental tropical air dominates. Precipitation is low, and vegetation is scarce. Many of these areas are located near the tropics. Thus, intense solar radiation results in high rates of evaporation and few clouds. Overall, evaporation rates exceed precipitation rates. The resulting moisture deficit gives the zone its name. Within this classification, there are two subtypes. You have arid regions, which are deserts, and you have semi-arid regions, which are called semi-deserts. Semi-deserts, like the one shown in Figure 8, are usually more humid than deserts. They generally separate arid regions from bordering wet climates because those climates don't have just a nice solid line where it's wet over here and it's dry over here. It's more of a gradient from low precipitation to high precipitation. Mild climates. So mild climates can be classified into three subtypes. You have humid subtropical climates, you have maritime west coast climates, and you have Mediterranean climates. Humid subtropical climates are influenced by the subtropical high pressure system or systems that are normally found over oceans in the summer. The southeastern United States has this type of climate. So if you're thinking humid subtropical, think Georgia and Florida. Their warm, muggy weather prevails during the warmer months, and dry, cool conditions dominate during the winter. So in the summer, you have this warm, muggy weather, and it's dry and cool in the winter. The marine west coast climates are dominated by the constant inland flow of air off the ocean, which creates mild winters and cool summers with abundant precipitation throughout the year. So you end up with these temperate rainforests. Mediterranean climates, named for the climate that characterizes much of the land around the Mediterranean Sea, are also found in California and parts of South America. An example of this type of climate is shown in Figure 9. So this is an example of a Mediterranean type climate. Summers in Mediterranean climates are generally warm and dry. because of their nearness to the dry mid-latitude climates from the south. Winters are cool and rainy, so summers are generally warm and dry. Winters are cool and rainy as a result of the mid-latitude weather systems that bring storm systems from the north. Okay. Continental climates. So continental climates are also classified into three subtypes. You have warm summer, cool summer, and subarctic climates. Tropical and polar air masses often form fronts as they meet in continental climates. Thus, these zones experience rapid and sometimes violent changes in weather, including severe thunderstorms and tornadoes, like the one shown in Figure 10. It's a tornado right there. Both summer and winter temperatures can be extreme, so you can have these extreme summer and winter temperatures because the influence of polar air masses is strong in the winter, while warm tropical air dominates in the summer. The presence of warm, moist air causes summers to be generally more wet than winters, especially in latitudes that are relatively close to the tropics. Then we have polar climates. So to the north of subarctic climate lies one of the polar climates, the tundra. Just as the tropics are known for their year-round warmth, tundra is known for its low temperatures. The mean temperature of the warmest month is usually less than 10 degrees Celsius. There are no trees in the tundra. Precipitation is generally low because cold air contains less moisture than warm air. Also, the amount of heat radiated by Earth's surface is too low to produce the strong convection currents needed to release heavy precipitation. The ice-cap polar climate, found at the highest latitudes in both hemispheres, does not have a single month in which the average temperature rises above 0 degrees Celsius. No vegetation grows in an ice-cap climate, and the land is permanently covered by ice and snow. Figure 11 shows an ice-cap polar climate. A variation of the polar climate called the highland climate is found at high elevations. This type of climate includes parts of the Andes Mountains in South America, which lie near the equator, but they're still very cold. The intense solar radiation found near such equatorial regions is offset by the decrease in temperature that occurs with altitude. So they're near the equator, but it is offset by the altitude. All right, microclimates. Sometimes the climate of a small area can be much different than that of the larger area surrounding it. A localized climate that differs from the main regional climate is called a microclimate. So a localized climate that differs from the main regional climate is called a microclimate. If you climb to the top of a mountain, you can experience a type of microclimate. The climate becomes cooler with increasing elevation. Figure 12 shows a microclimate created by the buildings and concrete in a city. So if we look at Figure 12 down here, you basically have downtown. You have a higher temperature here. You have a park. You have a lower temperature. You have this suburban residential area. The temperature goes back up. You get out to the farmland. It drops again. So heat islands. Sometimes the presence of buildings can create a microclimate in the area immediately surrounding them. Many concrete buildings and large expanses of asphalt can create a heat island where the climate is warmer than in the surrounding rural areas, as shown in Figure 12. The effect was first recognized in the early 19th century when Londoners noted that the temperature in the city was noticeably warmer than in the surrounding countryside. So heat islands again form when, well, it's the next section. Pavement, buildings, and roofs are made of dark materials such as asphalt, and they absorb more energy from the sun than the surrounding vegetation does. This causes the temperature of these objects to increase, heating the air around them. This also causes mean temperatures in large cities to be significantly warmer than in surrounding areas, as shown in Figure 13. The heat island effect also causes greater changes in temperature with altitude, which sparks strong convection currents. This in turn produces increased cloudiness and up to 15% more total precipitation in cities. So in cities, there is increased cloudiness and there is more precipitation. Heat islands are examples of climatic changes on a small scale. In sections 3 and 4, we'll examine large-scale climatic changes caused by both natural events and human activities. So I'm going to go back real quick to these convection currents here. And that gets us to the review questions.